Everyone saw Artemis II as a victory lap. 4 astronauts flew around the moon, came home alive, and gave NASA its biggest human spaceflight win in decades. But that is not what makes the mission important. What makes Artemis II important is that it exposes the real problem with sending humans to Mars. And that problem is not the rocket. It is not the launch pad. It is not even the landing. It is what deep space starts doing to people, vehicles, and mission logic before a Mars crew ever arrives. That is the mistake most viewers make with Mars. They think Mars is a transportation problem. Build something bigger than Saturn V, give it more fuel, give it more food, give it more computers. Problem solved. But crewed deep space missions are not engineering projects with humans tucked inside. They are biological missions that happen to ride on engineering. And Artemis II sharpens that reality. Not because the Moon and Mars are the same, they are not. But because once you leave low Earth orbit, the rules start changing in the same direction. Earth stops being close. Rescue stops being fast. Communications stop feeling immediate. Medical support stops being a handoff and becomes a judgment call inside the spacecraft. And every small weakness in the mission architecture starts compounding. That is why Artemis II matters as a Mars story. It is not a Mars rehearsal in the simplistic sense. It is a public demonstration of the exact category of mission where the easy assumptions break. The public story of human spaceflight is usually clean. Launch, cruise, arrival, return. A heroic line from Earth to destination and back. The real story is messier. Every leg of the mission is a stack of support systems, thermal systems, environmental control, consumables, navigation, crew performance, sleep quality, radiation exposure, medical readiness, vehicle integrity, abort logic, recovery logic. And on a Mars mission, none of those systems get easier as the mission progresses. They get more tightly coupled. That is the first lesson Artemis II pushes into focus. Distance matters differently than people think. For most viewers, distance means travel time. How many months to Mars? How long the engines have to run? How much propellant you need? Those are real questions. But biologically and operationally, distance means something else first. It means separation from support. The Moon is close enough that even when it feels far, mission control still exists as a practical partner. Mars is not. A Mars crew will spend months traveling away from Earth while carrying its own medical uncertainty, maintenance burden, and decision load. If something feels wrong, the mission cannot rely on the old model of call home, consult specialists, and prepare for quick recovery. The farther you go, the more the spacecraft becomes hospital, habitat, workshop, shelter, and command post all at once. That changes the meaning of even minor problems. A headache in low Earth orbit is not the same problem as a headache halfway to Mars. Poor sleep before a normal day is not the same as poor sleep before a navigation burn, a landing decision, or a high-risk equipment procedure. A malfunctioning sensor is not just a bad part if it undermines trust in the crew's understanding of the environment around them. That is why the phrase deep space mission sounds so clean and so misleading. It sounds like an extension of the missions we already know. In reality, it is a different management problem. The second lesson Artemis II highlights is mission duration. Artemis II is short compared with Mars. That is obvious. But the important point is not simply that Mars is longer. It is that long missions change the type of risk you are carrying. Short missions can absorb a surprising amount of inefficiency. The crew can tolerate sleep disruption because the timeline is short. The consumables margin can be generous because the mission is measured in days. The body can compensate because exposure windows remain limited. The crew can accept inconvenience because the trip ends before inconvenience becomes degradation. Mars removes that luxury. Months in transit means months of closed-loop living. Months of working, sleeping, maintaining, monitoring, and recovering in a sealed environment where the consequences of small disturbances accumulate instead of resetting. That is, when systems stop being independent. Slightly worse sleep can affect judgment. Slightly worse judgment can affect maintenance quality. Maintenance quality can affect environmental stability. Environmental instability can further degrade sleep and stress. And the mission does not break in one cinematic moment. It starts losing margin in slow, expensive increments. That is one reason NASA's health and performance research matters so much. The point is not to dramatize collapse. The point is to understand accumulation. Exploration crews are not threatened only by dramatic disasters. They are threatened by long chains of manageable problems that become dangerous when they overlap. Artemis II also forces a harder look at radiation. This is one of the most persistent illusions in public space content. People know radiation is a problem, but they often imagine it as a single number. How much dose? How much shielding? How much danger? And then they mentally file it as a solved engineering variable. NASA's own deep space biology work does not treat it that way. Beyond low Earth orbit, the agency still describes deep space radiation as a critical knowledge gap. That phrase matters. It means the environment is not fully characterized in the way mission planners would ideally want for long human exposure. It means some risks can be estimated, but not completely domesticated. It means Mars mission planning is happening around uncertainty, not after uncertainty has been eliminated. And that uncertainty is not just about cancer decades later. It reaches into tissue damage, immune response, the nervous system, operational fatigue, and the basic question of what long exposure does when paired with every other stressor already riding along. That is why Artemis II and Mars connect so cleanly. Artemis II does not answer the radiation problem. It helps illustrate why the radiation problem is mission-defining. Deep space is not simply empty. It is an environment with fewer protections and fewer interventions than crews are used to. If a short lunar mission already centers radiation cooperation, monitoring, and risk discussion, then a Mars mission turns that same problem into one of the main architectural constraints from day one. The public usually gives propulsion first place in the Mars conversation. A more honest ranking puts crew sustainability much closer to the top. And sustainability is not just food and oxygen. It is cognition. It is morale. It is medical autonomy. It is whether the crew can maintain a high-quality decision process after months of confinement, altered routines, and limited recovery options. That leads to the third lesson Artemis II sharpens. A crewed exploration mission is only as strong as its medical autonomy. This is a subject most space coverage avoids because it sounds procedural instead of cinematic. But Mars is full of procedural problems. What counts as a mission-ending event when Earth is too far away to help in time? What gets treated on board? What gets monitored? What gets ignored because there is no better option? What happens when symptoms are ambiguous? What happens when the crew has to choose between protecting one person and preserving the mission plan for everyone? The Moon begins that conversation. Mars makes it irreversible. That word matters. Irreversibility. Artemis II can come home. A Mars crew cannot spend months outbound and still pretend every major concern has an easy off-ramp. By the time a Mars mission is fully committed, the crew is living inside decisions that cannot be casually reversed. That changes mission psychology. It changes how carefully systems have to be designed. It changes how much autonomy the crew needs. And it changes how mission planners must think about uncertainty. On a short mission, uncertainty is often an inconvenience. On a deep mission, uncertainty becomes load. Load on the crew, load on the vehicle, load on the timeline, load on every decision that comes after. Artemis II also reminds us that spaceflight always ends with a final test the public tends to underestimate: re-entry. This is another place where Mars fantasies usually become simplistic. People talk about landing on Mars as though arrival is the hardest part, and return is a separate story for later. That is not how mission architecture works. Return capability shapes everything: how much you can carry, how much exposure you can tolerate, how much risk the crew absorbs on the outbound leg, how much thermal margin you need to preserve at the end of the mission. The public sees splashdown. Engineers see plasma, heat flux, material behavior, communications blackout, crew tolerance after prolonged mission exposure, recovery conditions. Artemis II compresses that truth into one visible sequence. The mission can look complete to the audience, while the spacecraft is still entering the most violent environment it has seen since launch. That is why Orion matters beyond its specific programmatic role. It is not just a capsule. It is a statement about what NASA thinks a human deep space return vehicle must be able to endure. And even then, the spacecraft is part of a larger argument. Because returning from the Moon is difficult. Returning from Mars is the same logic stretched across far harsher mission exposure. Longer transit, more degradation, more accumulated uncertainty. Then, after all of that, the crew still needs a vehicle and a body capable of surviving final entry and recovery. So what did Artemis II really prove about Mars? Not that Mars is next in a neat historical sequence. Not that a successful lunar mission automatically validates a Mars campaign. What Artemis II proves is narrower and more valuable. It proves that the real barrier to Mars is not one giant missing machine. It is a chain of smaller limits that stack on top of one another until they become mission-defining. Distance without rescue, duration without reset, radiation without full certainty, medicine without nearby backup, autonomy without instant ground correction, return without much error margin. Those are the real gates, and most of them do not announce themselves in dramatic fashion. They live in timelines, procedures, crew workload, biology, and margins that disappear a little at a time. That is why the public can misunderstand progress. A single successful mission can make it look as though the frontier is opening cleanly. In reality, a successful mission usually does something more useful. It reveals which problems are still quietly in charge. Artemis II does that for Mars. It tells us that the human future beyond the Moon will not be decided by a single engine. It will be decided by whether a crewed system can remain coherent when Earth stops being close enough to save it. And coherence is a much harder thing to build than hardware headlines suggest. You need propulsion, yes, but you also need medical logic, operational discipline, crew selection, radiation strategy, sleep protection, fault tolerance, psychological stability, consumables planning, entry margin, recovery margin. And above all, you need a mission architecture that acknowledges an uncomfortable truth. Human exploration gets harder, not only because destinations are far away, but because support moves farther away too. That is the strategic engine behind the Mars question. Not whether we can dream big enough, whether we can preserve human performance inside a system that gets less forgiving with every million miles. That is why Artemis II matters. Not because it repeats Apollo, because it shows the exact region where Apollo's model stops being enough. Apollo proved humans could go to the moon and come back. Artemis II helps show what has to be true if humans want to go much farther and still come back in one piece. And that is a bigger story than celebration. It is a consequence story. There is another layer here that matters for Mars more than most mission headlines admit. Closed-loop living. A short mission can tolerate inefficiency. A long mission cannot. Air has to be managed more aggressively. Water recovery matters more. Carbon dioxide removal margin matters more. Consumables forecasting matters more. And maintenance quality matters more because the crew is carrying its habitat with it instead of visiting one for a few days. That is one reason moon missions and Mars missions diverge so sharply after the first burst of excitement. The farther you go, the less room there is for anything wasteful, sloppy, or fragile in the support system. And support system is exactly the right phrase. Not life support in the narrow sense. Mission support in the full sense. Everything the crew needs in order to stay useful. Useful breathing, useful sleeping, useful thinking, useful repairing, useful deciding, useful recovering after a mistake. That is why Mars is so unforgiving conceptually. It turns human usefulness into the real payload that must be protected. If the crew arrives alive but degraded, the mission is already compromised. If they land with poor margin for error, the mission is already compromised. If they return with too much accumulated wear on the body and vehicle, the mission is already compromised. The frontier is not won when a crew merely survives. It is won when a crew remains operationally excellent across the whole arc of the mission. That is a much higher standard. And Artemis II helps the public see why that standard exists. Another underappreciated issue is timing, not mission duration. Internal mission timing. Every interplanetary crew will live on a clock built from procedures, maintenance cycles, observation windows, exercise demands, sleep scheduling, and unexpected events. That sounds administrative. It is not. Time discipline in exploration is physiological. If the schedule is wrong, fatigue accumulates. If fatigue accumulates, attention suffers. If attention suffers, procedural quality suffers. If procedural quality suffers, the mission starts consuming margin faster than planners expected. That is one reason sleep and circadian stability matter so much more than the public conversation reflects. When people imagine deep space danger, they usually imagine impact, fire, exposure, or catastrophic depressurization. Those dangers are real, but many exploration failures begin in more ordinary places. A crew that is not sleeping well. A decision made with less clarity than normal. An anomaly handled later than it should have been. A checklist that becomes harder to execute cleanly because the mission environment has slowly eroded the crew's sharpness. Mars is the kind of mission where ordinary human variance becomes strategic. That is why Artemis II belongs in a Mars conversation, even when it does not mention Mars explicitly. It is one of the clearest public reminders that exploration is about protecting performance, not just protecting life. And once you start looking at the mission that way, the whole Mars debate changes shape. The right question is no longer, can we throw enough hardware at the distance? The right question becomes, can we preserve crew quality under conditions that keep degrading support and increasing consequence? That pulls in another factor many people underestimate. Training transfer. A crew can train on Earth for medical contingencies, equipment failures, re-entry procedures, and habitat operations. But Mars does not reward training in the same way low Earth orbit does. In low Earth orbit, training exists inside a support net. Ground teams are close, experts are reachable, return paths are comparatively fast. On a Mars-class mission, training becomes a substitute for missing proximity. The crew has to carry more judgment inside itself. That means training is not just about knowing procedures. It is about knowing how to adapt when the procedure does not quite fit the reality in front of you. And adaptation under stress is exactly where biology, psychology, and systems design collide. That is another reason Artemis II matters. It reminds us that human exploration architecture is not only made of metals and engines. It is also made of habits, performance under pressure, and what happens when a crew must act without the comforting illusion that Earth can instantly intervene. The public often wants a yes or no answer on Mars. Can we do it? Are we ready? Is it happening soon? But missions this large almost never hinge on a yes or no answer. They hinge on whether the right set of margins is becoming mature. Thermal margin, medical margin, operational margin, cognitive margin, recovery margin. Artemis II adds evidence to that maturity question. It does not close the case, it refines it. And refinement is what actual progress looks like. You fly. You learn what stayed stable. You learn what became harder than expected. You learn which public narratives were too optimistic. And then you build the next architecture around the truth instead of the slogan. That is how Mars will eventually happen, if it happens responsibly. Not because one mission made it look inevitable. Because many missions slowly reduced the number of things we were only pretending to understand. If you want space explained by consequence, subscribe. The next briefing is about Europa and why one of the solar system's most exciting worlds is really a stacked engineering trap.